Okay, so this course, Introduction to Computing, basically addresses three areas of computing. Concepts, that's where we talk about hardware and software and the internet and things like that. Issues, this is where we talk about I guess issues that societal issues that have been I guess caused by or changed by the advent of computers. And then skills, that is skills that are particularly imparted in the computer world. So far I have talked about digital technology, I've talked about hardware. Those are both in the concept area. Today is the first time I'm going to talk about an issue, okay? And the issue I'm going to talk about is intellectual property rights. The intellectual property rights is not an issue that has been caused by computers. There would be the problem of intellectual property rights whether they were computers or not, but computers have certainly I guess changed the problems of intellectual property rights. What is an intellectual property right? Well, it says here on this slide, intellectual property rights concern the legal ownership and use of intellectual property, such as software, music, movies, data, and information. Intellectual property has sort of three aspects to it as far as the law is concerned. There are patents, there are copyrights, and there is trade secrets. So, what's the difference between a patent, a copyright, and a trade secret? Well, it's a little slow here. Yeah. Oh, sorry. Patents, that's one T. What's the difference in a patent, a copyright, and trade secret? Okay? So patents are handled by the patent office, right? And to get a patent on something, and that would be intellectual property, right? How do you get a patent on something? Well, you have to fill out a patent application, okay? And you have to file that with the patent office. How long is a patent good for? Patents are good for 15 years. Drug companies that come up with these really high-priced drugs, and they sell them at really high prices. You can't do a generic form of it, okay, if a company has a patent on it. But that patent will expire in 15 years, and then you can start having generic versions. How long is it? What's the difference in that and a copyright? How do you get a copyright? And what's the difference in a patent and a copyright? Well, patents are for usually some new idea, some device somehow. Usually there's something, you get a patent for a steamship, okay? You get patents for a cotton mill. You get patents for, some device. Copyright is really for books, for songs, for music, for usually written things. Copyrights are good for 99 years. And you file those with the Copyright Office. You just send a copy of whatever it is you want to copyright to the Copyright Office, and $5 or something, okay, and you get a copyright. Okay. Now, what's a trade secret? Well, a trade secret is something that's important, say, for your company and business. It gives your company an advantage over other companies, and it's just something that you keep secret in the company. You don't let it out of the company, okay? Trade secrets last as long as you can keep them secret, okay? And you have to treat a trade secret as a trade secret. That you got to tell the employees this is a trade secret. You're not to tell anybody else about it, okay? You don't put it up on Facebook right, or anything, right? You keep it a secret, right? Now, patents and copyrights are handled in federal court in the U.S. Trade secrets are handled in the state court. So, intellectual property rights concern the legal ownership and use of intellectual property, such as software. So if you create a piece of software, okay, that's intellectual property. If you create a song, okay, music, that's an intellectual property. A movie, any data, information, all of these things are intellectual property. Okay, in this section we're going to talk about piracy. Okay, this is not piracy at sea and ships and the like, but basically stealing somebody's intellectual property. That is stealing somebody's software, or somebody's music or somebody's movie. Now, we know there's a lot of this that goes on, right? We know particularly that there are some places in the world where it goes on much more, I guess, drastically than other parts, right? You know, countries have to have international agreements on these things. So, you know, if the United States, if you copyright something in the United States, then that copyright is protected in the United States. But suppose somebody in another country violates your copyright. Well, that's too bad. You don't, there's nothing you can do about it unless the United States has an agreement with that country to, each country is going to honor the copyrights in the other country. Okay. Now, these agreements are pretty broad based nowadays. Copyright agreements exist almost from every country to every other country, but not completely. And they're not enforced in some countries. We know that in China, they copy all of our stuff, right? The music, you know, the movies and all this, and there's these pirated copies that they sell, you know, at really reduced prices, you know, and don't do anything about it, and we can't get them to do anything about it. There's another issue to piracy. Okay, I've actually been an expert witness in a number of large court battles, okay, having to do with software piracy. And the cases that I have been involved in are like this. Here's some company, and it has some software that's important in its business. For instance, I guess one of the biggest ones I was on was life insurance. Here is this company that basically has software that it sells to insurance companies to run their insurance business. Life insurance is a very complicated thing nowadays, and doing all of the, I guess, work, you know, for running a life insurance company is very complicated. And so basically, they sold the most widely used software product for running a life insurance company. Then it happened that several of their employees quit. And these employees were the ones that basically had designed and built the software and been in charge of maintaining the software for the company. And these employees started their own company. And in a matter of a few months, they had a life insurance product very similar to the company they left, that they sold in competition with their old company. And the CEO of the old company felt like they had taken with them the software of the old company and had used it as a part of the building blocks for their new software. And basically he wanted this new company shut down. And so he brought suit, you know, the old company brought suit against this new company. And then the question came up of, well, is that true or not? Did they, you know, crib off the old company, yes or no? And so in the legal system of the United States, what happens is you get to a certain point in this litigation when the court orders what's called discovery. And in the discovery phase, the judge basically asked each company, what, you know, material, you know, do you want produced from the old company, the other company, the one, you know. And so each company has to produce material. You know, these can be emails, they can be documents, they can be the actual software source code, and whatever the companies feel like they have to have from the other company. This stuff that's produced is produced in confidence, you know, only for the purpose of the case for the court. So I was hired as a consultant, as an expert witness for the old company to look at this discovery material, particularly to look at the design documents from the new company, the actual software developed by the new company, and compare it, you know, to the source code of the old company. To look at the reference manual, you know, for the software of the new company, compare it to the reference manual of the old company, and so forth. And basically, I was told that, well, I was to do this in a fair way, and even though I was being paid, you know, for my service by the old company, if it didn't look like, you know, this was the case, I still had to say what my true feelings were in this. And well, as it turned out, you know, if you compare the reference manuals, they had just copied whole paragraphs from the old reference manual into their reference manual, you know. And you know, so basically I had to come up with all these comparisons. And this trial went on for a really long time. Well, finally, the old company won this case, and the new company was basically put out of business. But anyway, this is software piracy, one type of software piracy. Piracy involves the illegal copying, use, and distribution of digital intellectual property, such as software, music, and movies. Okay? People are more, I guess, interested in, you know, copying of music. Rolling Stones, Rolling Stones, Rolling Stones, Rolling Stones. And tell me the truth. Do any of you have any music or software or movies that you really shouldn't have? You can tell me. Well, I mean, it's part of, you know, it just happens, right? And it's not something we should do, right? But it is something that's done, you know, fairly broadly, okay? And now, you know, they're trying to crack down. The federal government is really trying to crack down on this right now. I mean, now if they catch you, you know, you're in trouble, you know. And that's what, you know, there's the internet shut down. A lot of people, Wikipedia shut down a while back, you know, protesting the government, you know. And they're saying, well, the government went too far. That, you know, they start shutting this down, then maybe the government will start censoring things, you know, and take away our freedom of speech. So it's a problem. By the way, I'm going to meet with the TA this afternoon, and we're going to put up the first discussion topic. And this discussion topic will be up for a couple of weeks, and we'll have it on later this week, maybe even as early as this afternoon. But it's not going to be on intellectual property. It's going to be on the Facebook IPO. Everybody knows right now Facebook has just announced it's going to have an IPO. What's an IPO? An initial public offering. What's that? It means that you can buy, after this offering, you'll be able to buy stock in Facebook, okay? And buy and sell it, okay? And it's going to be on some stock exchange probably maybe not the New York Stock Exchange. On the New York Stock Exchange, really only the really old, kind of, but on one of the newer stock exchanges, okay. Could be the American Stock Exchange, okay, or others. So this first discussion topic is going to be, what do you think about this Facebook initial public offering? What are your thoughts on it? Okay, and so think about it, okay, and maybe you can make a contribution, okay. So in fact, you should make a contribution because it counts 10 points of your out of 1,000. Right? 1 point, okay, on your overall, on your I guess final grade, but still, you want to think about it. Did you read this thing in the paper? There's this artist in New York, and Facebook got this artist to paint a mural in one of their, I guess, in their reception area, and he did, and they gave him, they told him, I guess they were short on money. They offered him stock options, and it's not often that a painter, a mural gets stock options, right? Normally stock options are for the real key people in the company, right? But he took the stock options, and painted him the mural. Didn't get any money, he just got the stock options. Now, if Facebook does go public, which they're planning to later this year, guess what his stock options are going to be worth? Did you read it in the paper? This painter's stock options are going to be worth about $300 million. That was an expensive mural. Not many painters get paid $300 million for a mural, right? And but had a picture of him and everything, That's what you call being in the right place at the right time, okay? And taking the right deal, right? Plagiarism. Plagiarism involves taking credit for someone else's intellectual property, typically a written idea, by claiming it as your own. Cut and paste. This is where you go to this is where you're writing your research paper, right? And you go to the internet and you cut a little piece out of the internet and paste it into your paper, okay? Without letting people know that's what you did. Now, if you put quotes around it or indent it and tell people this isn't mine, this is something I copied out of the internet, that's okay. But if you just paste it in and don't say anything about the fact that, well, you got this from somebody else, that's called plagiarism, okay? And it's a real problem, now, especially in computer science. We can get master's theses written, PhD dissertations written, and like in the case of this class, you're going to hand in your first paper, right? When's it due? This coming Saturday, right? So we don't want any plagiarism in these papers, okay? If you cut and paste anything out of the internet, okay, you have to, it was one sentence, you're supposed to put quotes around it, and you're supposed to put a little, reference to it. If it's a long thing, like a paragraph, you're supposed to indent it, and say where this paragraph comes from. Right? I mean, all that's in the explanation, that I, about the, the Modern Language Association's rules. Okay, I mean, I gave you copies, of how you do that. So digital rights management, or DRM, is technology that protects digital forms of intellectual property by restricting the number of devices and applications on which a file can be opened, and the number of times that the file can be copied and burned to disk. Now, it used to be software had no such protection. I mean, if you had a piece of software and it would say on a disk, you could make copies of that disk, you know, as many as you wanted, give to all your friends, right? And they could put it on their computers, you know, and they could make other copies, give it to other friends, you know. You could make hundreds of copies, you know, of the software, and everybody could use it. Okay? You can't do that anymore because there's things built into this disk and into newer computers and the like, okay, that check on things like this, okay, and so there are ways where the disk can know, you know, if it's been copied, it'll know how many times, you know, the previous version was copied, okay. If they added one to it, okay, that's the new, and if that exceeds a certain number, then it won't allow the copying here to be done. So that's good for people that sell software, okay? Because it cuts out this, you know, rampant copying, okay? But then people realize you have to start paying for this stuff, okay? And the Digital Millennium Copyright Act, it's a U.S. copyright law designed to reduce illegal digital media copying by criminalizing the production, distribution, and use of technologies designed to circumvent DRM technologies. Here's something from YouTube here, okay? I don't know, has anybody ever got this thing here? It basically says, we found out here you have something on your YouTube account that you shouldn't have, and we're not going to allow it, and if we find you having other stuff on your YouTube account you shouldn't have, we're going to shut your YouTube account down. Dear member, this is you probably can't read this because it's so small. This is to notify you that we have removed or deleted access to the following material as a result of party notification by limited, okay, that the material is infringing. And then there's the person here, okay, the citation. Please note, repeat incidents of copyright infringement would result in the deletion of your account and the videos uploaded on that account, okay. So that's the last slide in the slide set, and so I guess that's about all I had to say about it. So what's important here for the purpose of the test, okay, you should remember what what does DRM mean? DRM is Digital Rights Management, and it's technologies that have been developed to keep people from making more than a certain number of copies of the material that's been on a disk, you know, or other medium. And the Digital Millennium Copyright Act basically makes it a criminal offense to, you know, make copies of these things illegally. You know what piracy means, software piracy, plagiarism. Okay. Okay, for this week, and so start talking about software. So what's the difference in hardware and software? Hardware is hard, software is soft. So hardware is produced in a factory, right? Or at least in somebody's garage, right? And involves soldering, or taking a screwdriver and putting things together like that. Okay. Software is you write a program, okay, and you write this program in some program language. Okay. How do people create software? I mean, the computer science is really more concerned with software than hardware. So if I wanted to write a program to do something, I have an idea for a product, a software product, how do I do that? You write it. And what tools do you use to write software? Well, nowadays, you start with what's called an integrated development environment. IDE. And what's an integrated development environment? The most common used integrated development environment is Microsoft's it's called Visual. Let's see. Do I have it here? I guess I don't have it on this computer because it's a new computer that was just given to me. Called Visual Studio. And so this Visual Studio is some software, and it gives you an environment in which you can develop software. And so it's a little hard to explain, but there's different windows there. And some of these windows basically help you if you're, say, designing the user interface and what your window looks like. And you can insert these widgets, okay? And widgets are things like buttons that you push, okay? So you'll have your window and you can sort of drag in a button to push, okay? Or a file selector widget, okay? Or a slider widget, okay? It goes up and down, and so forth like that. There's other windows that basically bring source code, for a programming language. I guess the main thing is when you develop software, you have to decide about your programming language. Now, anybody Anybody in here written a program? Somebody's written a program, right? Nobody's written a program? Come on, you might have written a program. Little program. In high school. Well, somebody name me a programming language. C. Somebody name me another programming language. C++, right? There's not even a C++, there's a C++. Why is there a C and no C++? Yeah. Well, it's just in the C language, a plus means just add one to a variable. Okay? So C++ is kind of means more than C. You added a little bit to C. Name me another one. Objective-C. There is, for Apple, okay, and for writing for your iPhone, writing apps. Nobody's written an app for an iPhone. You wish. Well, not all apps, make money, but some of them do, and some of them pay right handsomely, right? There was this lady on television a while back. She was a grandmother, and she didn't have anything to do. All the kids were gone, and she was kind of sitting around the house. Her husband was still working, and kind of twiddling her thumbs. She decided she wanted something, to occupy her time. And her husband had this book that he just left lying around called "Developing Apps for the iPhone." She thought, well, that's interesting, and so she read this book, Developing Apps for the iPhone. And she got on the computer and she developed an app. She said, it was wonderful. Said, I got this app developed just in a matter of a couple hours. And, loaded up on the iPhone, and it said, "Hello World." She said, that was wonderful. And now she develops apps. She develops children's apps, okay? Little games, particularly for really young kids. And she said her app's done pretty well. She said she has an income now of about $400 or $500 a month coming from those apps. And $400 or $500 a month, not gonna make her rich, but it was kind of fun, little thing she did on the side, And as she gets good at it, she might come up with an app that really, takes off, There are multi-millionaires made on those iPhone apps, and you can make 4 or 5. They pay you by the sales, You get one that sells, you get to make a lot of money. Name me another programming language.
HTML.
What?
HTML.
HTML. Okay. Have you ever heard of a language called Fortran? Have you heard of a language called COBOL? These are the old ones here, okay? Fortran was really the first high-level language that was commercially successful. Fortran stands for Formula Translation. It was a programming language particularly for engineers and scientists. And it came out, the first version of Fortran came out in 1957. So it's, 55 years old now, really old. COBOL, I think, first came out right after that, right around 1960. And for many, many years, those two languages there were the only programming languages there were. COBOL stands for Common Business-Oriented Language. The Common Business-Oriented Language. And so it was for doing business applications. So Fortran was the language you used to do scientific applications, and COBOL was the language for doing business applications. And so, you know, yes, the COBOL so Fortran, that's a formula translation. And COBOL stood for Common Business Oriented Language. And some people didn't like it that there were these two different languages, okay? One for science and one for business. IBM came out with a language called PL1. This PL1 came out about 1960 something, 1964. Yeah. PL1 stood for Programming Language 1. And IBM said this is really the very first this Fortran and this COBOL don't count, you know, they were early. This is how a programming language should really be. Programming Language 1. And it's supposed to take the place of Fortran and COBOL. Both. That was IBM did that. Later, the federal government, the Department of Defense, came out with a language that called it Ada. And this Ada came out about 1970 something, okay. It was actually the Department of Defense. And this Ada was the Department of Defense language, and they said all new applications written for the Department of Defense, paid for by Department of Defense money, have to be written in Ada. This Ada was in honor of Ada Lovelace. Ada Lovelace was the daughter of Lord Byron. She worked for a guy named Charles Babbage at Cambridge and is widely accredited with being the world's first programmer. Neither one of these languages succeeded. They're both dead now. Nobody programmed them. Nobody programmed the PL1. They just died. Yeah. And in both cases, they had a really big backer, okay, but not big enough to convince people, you know, to stay with them. Okay? Well, the C language was developed by Bell Labs. That's the research part of AT&T. And it followed on, there was a language A and a language B, it's a language C, okay? And so there were kind of some research languages there, and ultimately this C sort of won out as kind of you know, the language of choice, okay, for many applications, okay. Now today there's still Fortran. People still program in Fortran. And particularly large scientific applications. And people still program in COBOL. But basically C. And then C was improved a little later by C++. These are really kind of the, you know, nowadays most programming is done in C and C++, particularly for personal computers. and the like. Okay. The C languages are good for both. You can do both scientific engineering applications. You can do business applications. They are sort of a low-level language, almost like a machine language. Okay. And then there's a brand new version of C called C#, developed by Microsoft. C# was sort of developed by Bill Gates himself, and it'll take over ultimately from C++. Now, when computers first came out, you programmed them in machine language. And then so you'd actually have to write this machine language, which was binary. And so you'd write the machine language like you'd say load, or say read. Okay. Read a number, okay, into machine location 0000001. Okay. Read some other number in the machine location 0000000. Say, I'm sorry, 5 be 101. No. Load load address 00001 into register 1. Okay. And load 0000101 into register 2. Add register 1 and register 2 and put it in register 3. Like that. That's how you had to program. That's programming in machine language. Okay? It was not a nice and pleasant thing to do. You know, it was hard to find people who would you know, work for this. Although people, you know, are weird people, you know, geeks, right, would put up with this, right? If you made a mistake, it's hard to find, you know, and writing programs was slow and cumbersome and error prone and all that. Okay? So quickly, people went to something called assembly language. An assembly language was looked like this. It would say read, okay, A, okay, read B, okay, load A into register 1, load B into register 2, okay, add register 1 to register 2 and put that in register 3. Okay. And so people program like that. Okay. And basically they typed each of these instructions into a card, we call it an IBM card, read that into the computer, and the computer changed this into the machine code. Okay. So there was a program called an assembler. And into this, you took this stuff here, you read it into the assembler, and the assembler came out with a machine language. The zeros and ones here. And this was considered to be a great step forward. It made the programming of a machine somewhat easier. But it still was very slow, very time consuming, and very error prone. Then they came out with Fortran. And so you could write this. Read input unit 5. Okay, read the number A from input unit 5. Read B from input unit 5. Okay, add A and B together and call that C, and print C on output unit 6. That's actual Fortran from that time. Although you could say print, or you could say write, either one. Then you would type all this stuff in on a card. Okay? Each one of these commands got typed in on a card, and you read these cards in. Okay? And there was something called a compiler. And all this went into this compiler. And this compiler translated that into assembly language. And then the assembler translated it into machine language. And this is the first high-level language again. So today, if you write something in, say, C++, okay, you'll write it, say, with Microsoft, the Microsoft, Visual Studio environment, and you'll create a file, okay, called, say, my program. .cp, okay. If it's C++, okay, it's a .cp. If you write it in C, it's .c. If you write it in C++, it's .cp. If you write it in Fortran, it's F, okay, or F90, or the various versions of Fortran. This is called the source code. Okay. Now, this source code will call on other. It's not really self-contained. You don't usually write everything, okay? The things that have already been pre-written, okay, libraries of things that have already been pre-written. So then you go through something called the link process. Yeah, and that's in this program integrated program development environment. And that comes out with a file called .obj, okay? And then you take that, okay? Well, actually, sorry. You go from CP to OBJ. This is the compiler. Okay, sorry. And then you link it, okay? And that comes out with something called myprog.exe. And that's the executable program. Yeah. It's a two-step process. You compile it and you link it again. Okay, software refers to the electronic instructions that govern a computer's action to provide a computing service. In this section, software engineering, acquiring software, software license, system software, application software, managing software. Well, what's more important, hardware or software? Years ago, when the computer business first started, you know, IBM was sort of the dominant. I mean, it basically had almost a monopoly on the computer business. And IBM basically sold these computers. It didn't sell software; it just gave the software free. Everything else was free. You bought the computer, it just gave you the software, or the manual, all this other stuff. Systems engineers that helped you write programs and things, all free. And then in those days, every IBM salesman had a little standard presentation that he gave to customers. It's called the iceberg presentation. And the presentation looked like this. Well, this is the iceberg. Iceberg. And the IBM salesman says, well, you know, when you see an iceberg, you know, in the ocean, all you ever see is the tip of the iceberg. That's the part of the iceberg that's above the water. But everyone knows that down below the water, the iceberg is much larger, okay, than the part that's above the water. He says, now when you do business with IBM, this tip of the iceberg that you see is the hardware. But below the water is the software and the services, okay, and the manuals and all the help, all of IBM's, you know, huge amount of help. That all comes in this iceberg. Yeah. And in 1970, actually, 1969, end of 1969, 1970, IBM unbundled this unbundling, okay, meant it was going to price everything separately. Yeah, from this point on, you had to pay for the software, you had to pay for the services, you had to pay for the manuals again, and all of this, okay. And then they said the hardware prices are going to go down because you're going to pay for this other, you can pay the rest of the iceberg separately. So the hardware prices went down by 3%. So this iceberg really was like this. But from then on, you know, this basically established the software business. Okay? Now, when the PC came out, IBM wasn't much interested in the PC because they're used to computers costing a lot of money. And basically, when Apple was being so successful, IBM came out with what's called the PC. Right? They did this with off-the-shelf components. Okay, they used a processing chip that was made by a company called Intel, and they needed an operating system. And they didn't have an operating system, so they thought they'd go buy one. Now it happened that Bill Gates' mother was a friend of a person who was on IBM's board of directors. And she said, my son has a little company, writes software. I'm sure they could give you an operating system, you know. And based on that, they got in touch, okay, with Bill Gates. And he went to him and said, you know, you want an operating system? No problem. My little company, Microsoft, we have an operating system. And so this guy, Paul Allen, was, you know, his partner was in there with him. As they left this meeting, Paul Allen said to Bill, Bill, you know, we don't have an operating system. And yet you just told this guy at IBM we have an operating system. And Bill says, well, I thought you told me you knew a guy, you know, that had an operating system. And Paul said, well, I do. He said, but, you know, I haven't talked to him about buying it or anything. But we'll go talk to him, you know. And he did, you know. And you know, he said, we have a customer, you know, we could probably use your operating system, you know. We'd like to buy it from you. And the guy says, how much are you willing to pay? He says, $50,000. Yeah, I said, $1? Yeah. So he sold Microsoft his operating system for $50,000. That was the basis for something called DOS, okay, which is the original DOS, okay, stands for Disk Operating System. And then so Bill Gates went back and they wrote a contract with IBM. And Bill Gates says, well, you know, this DOS operating system is the property of Microsoft. We want to keep title to it. Because, you know, if there's any changes to it or anything, you know. And the big philosophy at IBM was we're in the hardware business. Hardware is the important thing, you know. And even though they had unbundled, they still considered software to be not important. There's no problem. You want to keep it? That's great. You keep it. Okay? And so in the contract, Microsoft got to keep rights to the ownership, okay, of this operating system. And today, of course, Microsoft is a bigger company than IBM. And so it shows you, you know, things change, you know, with time. And I would say today the software is a much more important part of the computer business than hardware. Okay, so in the computer science, we teach something called software engineering. And basically, this is how you develop software. And it's kind of a, there's actually different ideas, you know, but basically software, particularly we're talking about enterprise type software, that is software that's for the whole big companies and the like. You start off by coming up with the requirements. Usually the requirements are badly written because they don't anticipate a whole lot of things. Based on these requirements, then you make a design, you know, then an implementation, verification, you know, maintenance. Usually you have to iterate, okay? After the design phase, you find out the requirements were inconsistent or incomplete, and you had to go back and change things, okay? After the implementation, you may have to go back again. So software engineering is the systematic process of transforming a software idea into functional software. In this section, computer programming, computer languages, application programming interface, or API. Computer programming is the process of creating software through the use of logic, algorithms, and programming language. Microsoft Visual Studio is a popular integrated development environment. IDE. Programming languages involves a set of symbols, keys, terms, commands, and rules to write a computer code. Okay, here's a little piece of computer code. This is in C or C++. Okay, you really can't tell the difference. Okay, here is the source program here. You go through this compiler. Okay, here's the object code here. A compiler takes source code and produces object code with an executable file and support files as output. An API is a set of programming tools provided to access an operating system or online service in order to create software based on that operating system. The use of an API opens up a system or device so that others besides the manufacturer can develop software to run on the system or device. Okay, acquiring software. Before I talk about that, there is another programming language I want to talk about. Anyone heard of Java? What's Java? Well, it's a programming language. It's very much like C++. Although it came out after C++ and is an improvement on C++. But there's one big special thing about Java. And that is, you can use a Java application without installing it on your computer. What you do, Java works differently. I mean, if something is written in C++, you have to compile it and link it, okay, all on your computer. You have to install it on your computer. Java, you don't have to install it. On your computer, what you do is you download the Java system, okay, one time, okay, and then basically if there's a Java program on somebody else's system, you know, there's a link to it on a web page, you know. Basically, you can link to it, you can run that program, okay. It basically runs what's called an applet. And you don't have to install it, which is considered to be a big advantage. Now, running it without installing it means that it may run a little slower than if you had actually compiled it and installed it on your computer. But the great desire for Java and use for Java and popularity of Java is all in this concept, okay, that you don't have to install the Java program in order to run it on your computer. So how do we acquire software? Off the shelf, okay? Then you go buy it, you know, at some software store. Or you can have somebody write it for you, custom design. Or you can do cloud computing. Now, what happens when you buy a piece of software off the shelf. You go down to some computer store, you buy some piece of software, and it's on a disk, say, and it's in a shrink wrapper, right? All wrapped up in this cellophane wrapper. Right? Okay, and you take this software that you bought and you pull it out of the shrink wrapper, you load it on your computer, and you install it. Okay, now, are you under any obligations to the owner of that software? Any contract exist between you and them about you bought this thing, it's yours, now maybe can't you copy it, you know, as many times as you want? Are you under contract? You are. All these software sold that away have what's called the shrink wrap contract. And in there, if you look carefully, it'll say, you know, by virtue of opening this shrink wrap, you agree to this contract. Okay? And that's legal. And so whatever that contract says, okay, you're actually bound by that contract. Okay? Yeah.
So, like, they verify.
What?
So they're like different contracts on product to product?
Well, the contracts tend to be very similar, of course. Okay, but yeah, they differ. You know, they'll differ on how many copies, how many you buy it. You know, maybe you can put it on one machine only, or you may put it on 2 machines or 3 machines. Okay, and that'll vary. Okay, from one software, you know, to another. Off-the-shelf software refers to software that's mass-produced or used by the general public, made available through outlets or retail stores. System requirements are usually printed on the outside of the box that contains the software or on the web page from which you download the software. If you download the software from a web page, yeah, the first little thing comes up as a window, you know, says, you agree to the following. Okay? You have to accept it, okay? So do you agree to the following, you know, license agreement? And you have to say, accept, okay? If you don't say I accept, it won't let you download it. Okay, okay, well, I'm out of time, and we're kind of in the middle of this. Okay? So I'll keep talking about this next time. I've got a whole bunch of stuff still to go there. Yeah, any last minute questions? Okay, thank you very much. Good.